Finding the area of parallelograms and triangles is not too difficult. If you can find the base and height of each shape, then you can plug it into the formula and you'll be okay. In our state, thankfully during state testing, they'll actually give you a reference sheet and you can look up, hey, what's the formula for finding the area of a parallelogram or a triangle, trapezoid, circle, etc. And so it's really just being able to look at the formula and look at the shape and know what you need. So in this case right here, we have a basic parallelogram. And again, all that means is that the two sets of sides are parallel to each other. So this left side is parallel to the right side, and then the top is parallel to the bottom. So this top side is parallel to the bottom side right there. Okay, so that does make it a parallelogram. That's all that we're talking about there. It could also be a rectangle. It could also be a square because it's two sets of parallel sides. Now, when we look at this, we need to be able to find the base very quickly. And the base is usually, unless they're getting tricky, and we'll talk about that later, is what the object is sitting on. And here it is, it's sitting on this side. So that's our base. Okay? Now, the height is at 90 degrees to the base, and it goes from the highest part of the object to the lowest point. So here is our height. Okay? And looks like we might need to make that a little bit of a lighter shade there. So let's try this one. There we go. So there's our height. Okay. Now, if I actually put in some numbers for this, I can then go and find the height and area and everything else that we need. Let's just say this is 9 inches tall by about 20 inches long. Well, all that you would need to do is say that A is equal to the base, which is 9 inches, times what's the, excuse me, the base is actually 20 inches, forgive me, times the height, which is 9 inches. And you pull out your calculator and you type in 20 times 9, and you very quickly see that it gets you 180. And if you can get the units right, then you'll be fine. Area is always in squared units, so you take the inches and put a second power on there. Okay, to the second power. That means 180 inches squared. Or you could write it out 180 square inches. Same thing there. Okay. Now, let's go through and take a look at a few other situations with these parallelograms. Here's two more situations. Okay. And again, we know that area equals base times height. Anytime that you see these dashed lines, it's not actually a part of the object itself. It's trying to show you, usually, the height of something from the highest point to the lowest point at 90 degrees. So this would be the height, okay? And then the base is whatever it's sitting on, or it should be where the height would intersect to where this is at 90 degrees. And you see there, these two lines would eventually, if you extended them, connect and hit at 90 degrees right there. So that's our base. So let's just say this is 10.6, and let's just say this is 8.7. No worries, you pull out your calculator, and you just plug it in the way it is. Base is 10.6 times the height of 8.7. Answer would be 92.22, or 92 and 2200ths. That's without rounding. And if we said that this was in miles, then we would need to say it's in square miles, or miles squared. This is a little bit of an extra trick where they put the height line outside of the parallelogram. Other times they'll put the height line inside of the parallelogram. So it could be outside or inside. So let's go back and do this one here. Here's our height. And let's just say that's 6. And then our base, well, this is the lowest point and it's intersecting the height line at 90 degrees. Let's just say this is 8. So area equals 8 is our base times our height, which is 6. We get 48. And if we said it was in yards, if each one of these was in yards, then our answer would be it's 48 square yards, or 48 yards squared. Last parallelogram that I wanted to show you real quick is what happens if they actually tilt the whole part of the parallelogram to where suddenly now this height line is horizontal. Well, it's not a huge issue because we already know that, you know, that the height is going to be shown at 90 degrees. So here's our height. That's what it is. That makes this the high part, and that makes this the low part, and it connects at 90 degrees. So this would have to come through and be your base. Now, let's just say that this is at 2 millimeters, and let's just say that this green side is at 7 millimeters. Well, area equals 7 times 2. So it would be 14 millimeters squared, or 14 square millimeters. Either way is perfectly acceptable way to express the answer in the correct units. Um, they will test will absolutely give you extra information. Like they could say, well, this is 3 millimeters right here. You don't need this side. You need the height and you need the base. So if you can find the base and height of parallelograms, you're fine. And this also works for squares and rectangles because they are just special parallelograms. You know, if this was a rectangle, this side is parallel to that side, and top is parallel to the bottom. Well, if this is 6 and this is 8, it's not difficult to see that, well, 8 would be the base, and then 6 would be your height, because from the highest part to the lowest part at a 90-degree angle, there's your height. So you'd use the same formula, A equals base times height, and it would be 8 times 6. So our area would be 48 units squared. If they don't tell you what these units are, you can just put in a generic thing of just calling it units, you know, 8 units by 6 units, and that can work as well. Since we're working so much with base and height, let's go through and pull in triangles. And again, we already know that the base is what it's sitting on, generally, unless they get a little tricky and they start messing with you. Let me go ahead and put in the right angles so that way we have those ready to go in just a second. So the triangle is sitting on its base, and let's just say that's 10 feet. And let's say this is 8 feet here. And when we're trying to find the height, remember, it's from the highest point to the lowest point at a 90-degree angle. So if this is 6 feet, we only need the height and the base for area of a triangle, because it's literally going to be 1/2 times the base times height. So we can go through and we can just put it into our calculator as far as 1/2 times the base, which is 10, times the height, which is 6, and we run it through our calculators and find out very quickly that it's 30, and then it would be feet squared. If this is 8, and this is 6, and this is 10, our height is from the highest point to the lowest point at a 90-degree angle there. So you're always looking for that 90-degree sign to help you with the height. And there's our base, because in this case it's 9 degrees to the height. So A equals 1/2 times 6 times 8. And 48 is what we get from 6 times 8, and half of 48 is 24. And I didn't have units given to me, so I'll just call it units squared. One other triangle I wanted to show you, and we'll actually mess with this one a little bit, but essentially it's like a parallelogram where they don't have to give you the height inside of the triangle. Sometimes they have to go to that side because that highest point is hanging over at 90 degrees over nothing, and so they have to do these dashed lines to show you. But you know what? This point right here would hit this baseline over here at 90 degrees. So technically the base is only from here over. But you can see that if we were to extend the base, it would hit the height line at 90 degrees. So if this is 6.1 and this is 13.2, we could go and plug it in. A equals 1/2 times 13.2 times 6.1. And so now we just go and plug it into the calculator, and we would get 40.26. And if we called this kilometers, using km for the units, then we would know that it would be kilometers squared. Now, as I stated though, basically they're going to do certain things to try and deceive you. They're going to throw in extra information, and they're also going to rotate this triangle around. Okay? For instance, if we rotated it just like this, and we added the right angle sign in again, what you're going to see is the following. We would say that, well, let's just say this is 15. Let's say this is 15.5. Let me put it out there to make it a little easier. Let's call this 29, and let's call this 23.2. So we've got lots of different numbers floating around out here. Again, what it comes down to is the following. You need to be able to find the base and height. Well, as it sits right now, it looks like this is at 29 for the base. The problem is that if you quickly just latched onto this and said this is your base, which one's your height? It's not 15.5. It can't be, because it's not at 90 degrees to the base. And it can't be 23.2 for the exact same reason. And then even though this has a 90-degree sign right here, I can't say that 15 is at 90 degrees to this 29 side. I can't, there's not a 90-degree angle here. So what it basically means is that we've actually got to go and rotate our papers around to see this. And suddenly we go, you know what? The height would be the 15 right here. This would be the 15 right here. Let me write this up the right way. I also know that it could not be the base sitting there in green. The base would have to be sitting down here. So my base is actually 23.2. And then on top of that, my height is from the highest point to the lowest point at 90 degrees. So my height is 15. My base is 23.2. I don't care about this side, and I don't care about that side. And now I can just plug it in, and I'm able to go with it. So 1/2 times 23.2, I'll put this in parentheses, times the height, which is 15, and we're ready to go through and get the area of this triangle. But again, it's not where they're not giving you the information, they're just doing something subtle like giving you extra information, or taking it to an extreme and actually spinning the triangle around to where you may not be able to recognize the base and height. After you plug it all in and multiply all three numbers together, the 1/2, 23.2, and 15, you would get an answer of 174 exactly. So 174, if we use centimeters, and that's what we'll use here, then it would be centimeters squared.